Okay, today our topic is energy. There is strength 2, energy, and the sub-strength is work done, power, energy. So before we begin, what do you understand by the term energy? Okay, very good. Okay, now let's come to work done. Work done is what?
Can be defined as force applied through a distance.
Partially correct.
Distance. Force applied in distance.
Yes, come on.
Work done in a given time. Work done in a given time.
What done is a force that already applied on the object.
Like for example, let's say a particular box, right? You are having a particular box and you want to shift it from one position to the other position, right? So if you are shifting something, that means the work done has been done on that particular object. That's why we say work done is equal to force times distance or displacement. Very good. Right? Force times displacement. Because that box at the moment is its initial position and it's been shifted from one position to another position. So that's why we say work done is equal to force times displacement. Very good. What about power? Okay, very good. And then energy. Right, very good. Let's begin. So objective for this lesson, at the end of the lesson, you should be able to figure out work done, power and energy. Right? Okay, work done. As I mentioned, when force moves an object to a certain distance, either to impart acceleration or to overcome the frictional force, work is said to be done. For example, you come in front. Okay. Just get the chair. Okay. So at the moment, this chair, right, is on the floor at the moment, right?
Yes.
So can you leave this chair? Right. So amount of work done on that particular object, yes or no?
Yes.
Any work done has been done on that
Yes.
particular object? Yes. Why?
Because it
That's
is
right.
moved from the
Right.
initial position.
Right. Because the chair has been moved from its initial position, right? Now it's carrying, right, the chair at this height. So therefore work is done on this chair. Yes or no?
Yes.
Let's say he is moving with the chair. Move. Now any work done on that particular chair?
No.
Why?
Because the person is moving on the chair.
Very good. Because the person is moving with the chair, not chair is moving by itself. Right? For example, right? So we have elaborated on that. Now work done is equals to force times distance. Because he will apply some force in order to lift it. Understand? Yes. So that's why we say work done is equals to force times displacement. Right? Or distance you can say. Very good. Okay. So what is the unit? Thank you. Now, what is the unit for work done?
Joules.
Right? Or you can say newtons per meters. Why? Because force, the unit for force is in newton,
Yes.
and the distance should be in
Meters.
That's why. So it will be like this. Work done is equals to force times this distance or displacement. So force say you have a force of 10 Newton, and then displacement, let's say that particular box has been shifted. Let's say he applied force of 10 Newton on that particular chair, and the distance, right, the chair traveled from the height he was, right, lifting at that height was, let's say, 0.5 meter, right? So it will be 5 Newton meters. It will be Newton meters, right? Or you can say
Joules.
by Joule. 1 Joule, we can say now 1 Joule is equals to 1 Newton meters. Newton meters, eh? 1 Joules is equals to 1 Newton meters. It's not division, it's multiplication. So not Newton per meters, it should be Newton meters. Per means divided. Okay, also right. Now let's do this example. If a girl pushes a box with a 5 Newton force and let's say this one is box. Box travels 200 centimeter in the direction of a push. The amount of work done will be, so you know work done is equals to force times distance or displacement. So force there is what?
5.0.
5 Newton, right? Times. Remember your displacement should be in meters. Right, very good. So how do you convert, right, your distance into meters? That will be 200
Divide by
100. That will be
100.
2
Meters.
Very good. Okay, so now replace in place of displacement, you replace your
2 meters.
distance, which is 2 meters. So what will be your work done?
10 meters.
10 Newton meters, or you can say 10 joules. All good?
Yes, sir.
Now, let's move to energy. Energy, as I mentioned, the capacity for doing work, right, on a particular object. So the simplest case, can you note it down?
Yes.
Noted. See. Okay. The simplest case of mechanical work is when object is standing still and we force it to move. Right? The energy of a moving object is called kinetic energy. That means if something is moving, right, it has which energy?
Kinetic energy.
And if any object is at particular height,
Potential
potential energy, very good. And if let's say if any object is moving at a certain height,
mechanical
energy. So right, very good. So mechanical energy, total mechanical energy, right? If an object is moving at a certain height, then it will have potential energy plus kinetic energy. Very good. Right? If let's say any object, right? Any object is at stationary position but it's at a certain height, right? It will have, for example, let's say this is a slope. This is a slope, right? I'm talking about, let's say this is point A. This is point B. This is point C. Right. So at the moment at point A the object is at stationary position. That means it's not moving at all. Right? Very good. Okay. Now, what energy the object A will have? Remember, this object is not moving. At point A now. So, which energy that object has? It will only have potential energy because it's not moving. So something that is not moving, it cannot have kinetic energy. Yes or no?
Yes, sir.
Right. Now at point B.
Both.
Right?
Mechanical
Energy,
energy.
right? Mechanical energy has both potential energy plus kinetic energy. Why? Because now it's moving. Right? The object is moving and it's at a certain height. That's why we have both potential energy and kinetic energy. And what about at point C?
There's only kinetic energy.
Why?
No height.
No height. Very good. Very good. It's at a ground level, right? Okay, let's move on now. Okay, power. Okay, power as I mentioned is defined as the work done at a given period of time. So power, what is the unit for power?
What?
1 watts is equals to what? Joules per second. 1 watts is equals to joules per second. Very good. Right. So this is the formula, power is equals to work done divided by time. Right? This one says joules per, if I'm saying per, it's saying it divided by seconds. Right? So joules, that is your work done divided by time, which should be in seconds. This is in joules. Okay? All good? Yes. Right. Okay, this is the example. Let's say a man applying a force of 15 Newton on that particular object or box, let's say, and it took him, right, to travel at that particular distance 6 seconds, right? So I want to know what was the power of that particular man that was applying the force of 15 Newton on that particular object, right, to move a certain distance, right? So therefore, you know power is equals to work done divided by time. So remember, work done should be
Force times.
what is your work done?
15. No, work done is force times distance.
Right. Force times
Distance.
right? Force times distance divided by time. So now force is what?
15.
Newton times distance 8 meters. Very good. Divided by 6 seconds. What do we get?
20.
meters per second.
No.
It's not speed. See, the answer can be 15 times 8 is what?
It can be
120. 50 times 8 is 120.
120. That will be Newton meters. Divided by 6 is what?
20.
20, right? So your unit can be 20 Newton meters per second
Or what?
or
watts.
related to one another?
Yes.
Right. Now mechanical energy, right? Right. Mechanical energy, it will have both potential and kinetic energy if that object has a height and is moving. Right? As we mentioned before. Right. So it says potential energy is equals to 0 on the ground level.
Yes.
Right? So if the object is moving but don't have a height, so definitely it won't have a potential energy. So now gravitational potential energy is the energy stored in an object as a result of its vertical position or height. As I mentioned, the energy is stored as the result of the gravitational attraction of the earth for the object. Right? Gravitational acceleration is what? It's a constant which is 10 meters per s square. That is gravitational acceleration. Right? So this is the formula to find potential energy. So potential energy is equals to mgh. So it's dependent on the mass, gravitational acceleration, and the height of the particular object. Right. So EP you know is the gravitational potential energy. Right? Gravitational potential energy, that will be joules. Right? M is the mass of the object, that should be kg. And G is the gravitational acceleration, which should be in and H is the height, which should be meters. Very good. Okay, let's look into this example. Okay, a trolley of mass 0.9 kg moves at 10 meters per second until it comes to a downward slope. So that means this trolley is moving, right? It's moving. It's not at stationary position at point A. It's moving at the moment with the speed of 10 meters per second. So our task is to calculate the potential energy of the trolley at point A. So potential energy, what is the formula?
mgh.
So beside it, first whatever information you know from the diagram, you can note it down beside it. So what is the mass of the trolley?
0.9 kg.
So our mass is supposed to be kg. So it's already kg, not kgs, right? And then what is our gravitational acceleration?
10 meters per second.
10 meters per s squared. And what is our height?
10 meters.
10 meters. Our height should be in meters, right?
Yes.
So it's already in meters. We don't have to do anything. Just replace in this formula. So mass is 0.9 into
10 into 10.
10. What do you get?
90. 90.
90.
Yes.
91.
Joules.
Very good. Okay. So we have done with part 1. This is our potential energy at point A.
Yes.
Right? At point A, part 2 says calculate the kinetic energy. Right? Kinetic energy of the trolley at point A. So kinetic energy at point A is what? So what is the formula to find kinetic energy?
Half mv squared.
Half
mv squared.
So mass is what?
0.9
kg. And what was the velocity? 10 meters
10 meters per second.
Right?
10 meters per second.
10 meters. So half mass is 0.9 and velocity there is 10 squared. Eh? So half times 0.9 times 100, what do you get as kinetic energy? 45 joules.
4.5
in square.
Oh, yeah.
45. 45 right? So if I'm asking you what is the total mechanical energy at point A, then
So you plus.
125. 45 plus 90.
very good, right? So total mechanical energy at point A, because at point A the object is moving and it is at a certain height. So therefore it will have both potential and kinetic energy. So the total energy of that particular trolley will be 90 joules plus 25 joules. Very good. So what is the potential energy of the trolley at point B? So part 3 now. Part 3, what is the potential energy of the trolley at point B? Right. This is the general question. Potential energy at point B.
Point A is 0.
Why?
There's no height.
Very good. Yes. Therefore, potential energy at point B is 0. Since there is no height. Since there
Is no certain height
is
given.
no height. Right?
Yes,
Very
sir.
good. Very good. Okay. Now part 4. Calculate the kinetic energy of the trolley at point B. So kinetic energy is what?
Half mv squared.
Half mv squared. So half mass is what?
0.9 kg.
0.9 kg, and the velocity is
10.
sorry.
Velocity
Calculate the
is
kinetic energy of the trolley at point A. So you know kinetic energy is equals to, there is no height,
so it is
right? There is no height. So all the mechanical energy will be converted into kinetic energy.
so it
Yes
is
or no?
not 135.
So we cannot, therefore we cannot use this formula because your kinetic energy, note, there's an important note there, note, kinetic energy, right, mechanical will be converted to kinetic energy at a ground level. So all its mechanical energy will be converted into kinetic energy. So what was the total mechanical energy?
125 joules.
Total mechanical energy
125
at point
joules.
A, it was, what we need to do, total mechanical energy is equal to potential energy plus kinetic energy. So potential energy in part 1 was
95.
90 joules plus kinetic energy in part 2 was 45 joules. What is the total?
185 joules.
185 joules. So therefore, since my doubt is mechanical energy will be converted to kinetic energy at the ground level, so therefore will be kinetic energy equals to
125 joules.
very good. Got it now?
Yes, sir.
Right. So now last part is
B. Calculate the velocity of the trolley
At point B.
so now part B is to find the velocity, right?
Velocity
Of
of
the
the trolley.
So velocity at point
B.
B. So we know our kinetic energy at point B is what? 135 joules. Very good. So we know kinetic energy is equal to half mv squared. Very good. So kinetic energy in place of kinetic energy, I will substitute 135 joules. Or it's better you decided you write whatever information you know, for that particular question. So we know kinetic energy, which is 125 joules, and we know mass, which is 0.9 kg. Yes or no? Can we find V now? Yes, we can. Right? So 125 is equals to half. Mass there is what? 0.9. And then B squared. Because we don't know what is B. B is our velocity, which we don't know.
Yes.
Right? So 135 equal to half times 0.9. What do you get? 0.45 B squared. Now what is your next step?
Minus 0.45.
No, divide by
Oh, yes,
0.45.
because they multiply.
Yes, it's 0.45 times B squared. So opposite operation is divide by 0.45 divide by 0.45. So B squared is equal to what? 300.
Square root.
So now next operation,
Square
Square
root.
square root on both sides. So B is equals to what?
17.32.
17.32 what?
Meters per second.
Meters per second.
Meters per
Second.
second. Got it?
Yes.
Right.
Yes, sir.
Okay, we finish here. Okay, your exercise